Hello, scholar. Can you keep up with the lessons so far? If you do, then let's not waste any more time and proceed to our third lesson, which is about conditional propositions. If P and Q are propositions, the compound statement, if P, then Q, is called an implication or conditional statement and is denoted by P implies Q. P is called the hypothesis, or antecedent, and the proposition Q is called the conclusion, or consequent. The truth value of the conditional proposition, also called an implication, P implies Q, is defined in table. Notice that the proposition, if P, then Q, is false only when P is true and Q is false. That is, true statement cannot imply a false one. If P is false, the compound proposition is true no matter what the truth value of Q is. For example, the compound statement P implies Q, and Q implies P, is a conjunction of two conditional statements. In the first conditional statement, P is the hypothesis and Q is the conclusion. In the second conditional statement, Q is the hypothesis and P is the conclusion. Observe that the truth values for the conjunction, P implies Q, and G implies P, are always the same. Also, the truth tables for the disjunction, P or Q, and Q or P, are identical. However, it is false that the truth values for P implies Q and Q implies P are the same as seen in the truth table. Now that you've got the gist of it, here is a truth table for truth values of the conditional proposition. Given the conditional proposition P implies Q, then the converse of P implies Q is the implication Q implies P, and the contrapositive of P implies Q is the implication not Q implies not P. The inverse of P implies Q is the implication of not P implies not Q as seen in the table below. Be sure to remember the truth table for conditional propositions so you won't get confused in our next topic, which is biconditional propositions. If you're all set up, then click the link in the description and proceed to our next lesson. See you there.